Okay, so I want to say a couple things about factoring because factoring is going to help us with simplifying expressions and solving equations. We do it a lot. And in particular, I want to talk about factoring expressions that have variables in them. So I first want to talk about a few common forms of these expressions, things that you'll see a lot. And if you can just remember how to factor them, that's going to help you follow arguments where that's used and not get slowed down by wondering, wow, how did they do that? Then the other thing I want to talk about in this video is kind of a process for factoring some expressions. It's not a process that's going to work all the time, but it works often enough for simple examples that it's worth your effort to be familiar with it. Okay. So on these common forms, there are three common forms of expressions that factor easily. Okay, so the first one is the form x squared minus y squared. That factors to x plus y times x minus y. Okay. And you'll even hear this called the difference of perfect squares. Okay, over here, this is the difference of perfect squares, factors into the product of a sum and the difference here. Second common form is x squared plus 2xy plus y squared. That equals x plus y squared. And the third one is almost the same, but one critical difference, x squared minus 2xy plus y squared is x minus y squared. Okay, so a couple of comments on these. In several of the last videos, I've talked about x plus y in parentheses raised to the power 2, how important it is to not think that that equals x squared plus y squared. Well, maybe it's easier if we remember what it really does equal to. There is an x squared and there is a y squared, but there is this middle term here. If you, instead of squaring the sum of x and y, you're squaring the difference of x and y, it's the same except for the sign on this term that has both the x and y in it. Okay. We might want to check that these actually work. And the way to check any kind of factoring is just to multiply out. You say these are factors, it means that they better multiply out to the thing that you factored. So looking at the difference of perfect squares and multiplying that out, multiplying the x times the x gets x squared, the x times the negative y minus xy, the y times the x plus xy, the y times the negative y minus y squared. These two terms cancel out. It does check. Maybe I'll skip the middle one since there's no space. I didn't leave myself space to write here, but I'll check the square of the sum because I think that'll be enough for you to see the process here. I like to write it out if I'm going to check it. X minus y times x minus y. That's what x minus y squared means. Multiplying the two x's together, I get x squared minus y times x. Minus x times y plus y squared. Now these two interior terms don't cancel. They both have negative signs on them, so we can combine them. And we get x squared minus 2xy plus y squared. That is indeed what we started with here. Okay. Just so in doing these few lines of algebra here, I was using those rules of algebra like crazy. I was using the distributive law to multiply out these terms. I used the commutative law to notice that y times x and x times y are the same thing. Then I used the distributive law again to put those two together and say, well, I've got one product of x, y, and another one here. That means I have two of them. So I'm doing these, I'm kind of doing lots of steps together. Anytime you feel like you're not quite sure what I'm doing, slow down and pick them apart. It's never a problem to go too slow. Okay. One other comment on these forms. So the idea in writing them out here with the x's and y's is they're not always going to look like this. A lot of the time, we'll have only one variable here. So for example, if you see something like x squared minus 36, ideally you'll recognize, oh, 36, that's a perfect square. That's 6 times 6, and we can factor that into x plus 6 times x minus 6. Or kind of continuing that same example, I have x squared plus 12x plus 36. Again, what I'm looking for is factors of this term that will sum to, what I'm noticing here is that this is a square. I'm getting ahead of myself there. So what I'm really noticing with this term is that this is 6 squared, and this is 2 times 6. Okay. And in doing that, let's say that looks like x plus 6 squared. For both of them, then I would check. I'd multiply that out and indeed get x squared minus 6x plus 6x minus 36 equals x squared minus 36. So hooray, it checks. The other one's going to check too. Okay. So main point here, these three forms are something you'll see. Sometimes they'll be hiding. Sometimes the what's squared is itself a complicated expression that you'll have to do some algebra to even find that. But recognizing these common forms will help you simplify things that otherwise might be hard to simplify. All right. So that's one thing. The other thing I want to do is talk about this sort of guess and check technique. So let's go to a new page here. And what am I talking about with this? Okay, what I'm thinking about here are expressions that have a slightly more complicated form. They have a form that looks like this: x squared plus a plus b times x plus the product of ab. Okay. I'm going to assert that that equals x plus a times x plus b, and just like always, we're going to check. And that is going to be x squared plus xb plus a times x plus ab, and that will indeed be x squared plus a plus bx plus ab. Okay. So when you find yourself looking at an expression where the x really is the variable, but a and b, the idea here is that we can get these really are numbers, where you've got a number here by itself, look at that and kind of think what its factors are. And as you're thinking about the factors, are there pairs of factors that if you add them up will get you to the number multiplying x without an exponent? If there are factors like that, those are the factors you guess. They might be the factors, and then you try to check them. Okay, so to kind of wrap our brains around this, what I want to start with here are, I want to start with factors. Okay, so let's say we multiply x plus 2 times x plus 5. Okay, so I'm going to start here with this right-hand side. And what do I get to here? I get x squared plus 5x plus 2x plus 10. That is x squared plus 7x plus 10. Okay, this fits. This fits our form here. We've got a is 5, B is 2, or you can switch them around. Doesn't matter which one's A and which one's B. Okay, let's do another example like that, just to get familiar with it. This one, let's have a negative sign. Let's have it be x minus 3 times x plus 6. Again, we're just going to multiply it out. X squared minus 3x plus 6x minus 18. I'm being careful with my negative signs here. So when I multiply the negative 3 times x, I get a negative 3x, and I multiply the negative 3 times the 6, I get a negative 18. Okay, that's fine. Combining terms here, I get x squared, negative 3 plus x. Okay, that gives me a plus 3x minus 18. Okay, so again, it's going to fit my format here with a equals 6, 6, and b equals negative 3. Okay, so now let's do this the way we normally would. Like this was sort of validating the formula. Let's actually use the formula to factor this expression. Okay, so if we just had x squared plus 7x plus 6, and we want to factor it, first thing we do is we ask ourselves, okay, what are the factors of 6? Well, one set of factors would be 2 times 3 is 6, but that's not getting us anywhere because 2 plus 3 is 5, and that's 7. Okay, so that's no good. What's another pair of factors of 6? Oh, 6 times 1, those are factors of 6 too. And 6 plus 1 does indeed equal 7. Okay, so let's guess those. So guess that x plus 6 times x plus 1 might equal that expression. And let's check it. Same way we've been doing, just check it by multiplying it out. X squared, multiplying this times this, plus x, plus 6 times x, plus 6 times 1, indeed does give me. So that's guess and check factoring in action. I look at the term that doesn't have any x's. I think of different pairs of factors for that term. If any of those factors add up to 1, sorry, not add up to 1. If any of those factors add up to the term that's multiplying x by itself, the linear term, we would call this, then I guess to see whether those will be the a and the b in this general form here. Okay. So I've got another video with a few more examples involving some negative signs. Check that out, or just go right to the problems and do some practice factoring these guys, and you'll be in great shape to go.